Hello and welcome to the Aggregation Webcast. In this quick session, I would like to show you the new aggregation feature by XAP In-Memory Data Grid. The new aggregation feature enables us to run aggregation query over a big data application. However, before we start understanding how the feature works and how to utilize it, we need to understand the challenges we face in this situation. When it comes to big data applications, we already know that a huge amount of data flows through the system. We also know that this application needs to be highly available and that the application must comply with very high performance requirements. Our main challenge here is that we need to support complex querying. Now, the complex querying in that case may not just be key value query or SQL filtering. We also need to group by minimum, maximum, and so on. Most applications still have the need for real-time analytics. In relational databases, we can easily implement this with aggregations. Those aggregations, as we said, can be averaged minimum, maximum, sum, group by, halving, and so on. In a distributed environment, it's much more complex since the data is partitioned across the cluster. To aggregate it means we need to bring either all the data from the server to the client, which is not an option because that's a lot of data, and the client will not be able to handle this. Also, we need to pay attention to the latency that will be affected by bringing the data from the server to the client. Our other option is MapReduce logic, that would basically perform the functionality in each partition. And then the results from each node or partition would be sent to the client. The client is responsible for the reduce part that aggregates the final data for this calculation. Now, this option is fine, but it's not very intuitive, because for every single query, we will need to write code, custom code, that will do the MapReduce function. So if we take this example and see what we have here, we'll see how we can exactly utilize XAP to do that for us. Here we have a person, Pojo. This person, Pojo, has few fields: ID, age, country, department, sex type, and salary. That's a very simple Pojo. There's nothing too sophisticated here. And here we have the random SP application that's creating an embedded space, as we can see here. Of course, we can also create a space outside and then connect to the space. In that part, we create the objects that we will do the aggregations for. So we create basically 100,000 objects. That's not very big data, but that's good enough for the example. As we can see here, the objects that will be created are using random values for the following fields: salary, random department, sex type, and country. Now we have a few examples. So the first example is actually very simple. We have select average salary for employees grouped by department. So we want to see all the departments and the average salary for these departments. This example in XAP would look like this. We have a group by function. In the group by function, we send the gigaspaces proxy. Then we send the query. The query condition is empty. And we have the group by aggregator. The group by aggregator is set to group by department, and then we select average salary. Let's take a bit more sophisticated example that would look that way. Select average salary, minimum salary, maximum salary from employees, where the age is older than 50, and group by both department and sex type. In XAP, it would look like this. We create the query. For the query, we specify that we want age to be older than 50. And we send the query with the gigaspaces proxy to the group by function. This time, we create also department and the sex type in the group by function. And we choose to fetch also the average salary, the minimum value of the salary, and the maximum salary. So that's another sophisticated example. Now, let's use an even bigger example. This way we have one with having that in SQL, and it would look like this. Select average salary, count from employees, group by department having average salary higher than 18,000. In XAP it would look this way. We group by function as we've seen before. We send the proxy, we send the query, we send the group by aggregator. And in the group by aggregator, we send again, group by department, average of salary, count, and now we have something that we haven't seen before. A halving block that will specify the exact functionality for which we do the halving. The halving in this case will be the group by value get double average salaries. Since this is what we want to have the halving on, higher than 18,000, we are going to print the results. So let's see how this example runs. We start the space. At the beginning, we start the first function. For the first function, as we see, we select average salary from the employees group by department. Exactly that one. And we see that we get the results. Sales, just the first one, and we print it. Average salary of sales is $19,975. Then, the next one that we're printing the value is the halving example. The halving example returned 2 items as we see. It returned a group by result. We iterate these results, and we have only 2. Why? Because we have only 2 departments. So the first one is marketing, and the marketing average salary is $19,991. Now, this salary is obviously higher than $18,000. And the second one is sales, which is also $19,975, which we also remember it from the first one. That's it. That's how we can use the aggregation feature by XAP. It's very intuitive and very easy to use. It runs on the server side, and therefore the latency is very low. This also allows for high throughput. Feel free to use it. Thanks for watching.